Hello everyone, I am Saminathan, Assistant Professor, Department of Mathematics, SNS College of Technology. Today we are going to start our session with the basics definitions of matrix and calculus. Already we know the definition of matrix. The rectangular arrangement of an element is called matrix. Let us see the first topic, eigenvalues. Let X be an eigenvector of a matrix A. Then there must exist an eigenvalue lambda such that Ax equal to lambda x. Or equivalently, we say Ax minus lambda x equal to 0, which means that A minus lambda I into x equal to 0. If we define a new matrix B which is also A minus lambda x. If B has an inverse, then x equal to B inverse 0, which is equal to 0 matrix. But eigenvector cannot be 0. So it follows that x will be an eigenvector of A if and only if B does not have inverse. Which means that let us taking B equal to A minus lambda I. Therefore, Bx equal to 0. It is not satisfying the condition a minus lambda I into x equal to 0. Therefore, B does not have inverse of the A. So, determinant of B not equal to equal to 0, or determinant of A minus lambda I equal to 0. So, this is called the characteristic equation of A. Its roots are eigenvalues of A. Next, we see the definition of eigenvector. When we solving the characteristic equation, the roots are the eigenvalues, and the eigenvalues will be obtained from the characteristic equation. So there exists non-zero vector Ax equal to lambda x. Then the vector x is called eigenvector corresponding to the eigenvalue. The definition is eigenvalue of the definition, a scalar that indicates how much an eigenvector is stretched or compressed during linear transformation. Eigenvector, a non-zero vector whose direction remains unchanged when the linear transformation is applied. Only its magnitude is scaled by eigenvalue. Eigenvalue indicates how much an eigenvector is stretched composed during the linear transformation. The key points, that is the eigenvector linked to an eigenvalue. Eigenvalues founded by solving characteristic equation. Next, eigenvalues and eigenvectors in engineering, structures and buildings. Eigenvalue, how fast the structure vibrates, natural, that is the natural frequency. Eigenvector calculated as how structure moves while vibrating. So value as the oscillation, and value is the speed of oscillation. Eigenvector, the direction of the vibration. In electrical and power systems, eigenvalue stability of the system. Eigenvector is the response pattern of currents or voltage. In control system, the value determines if system is stable. Eigenvector, it shows different parts of the system. Aerospace or robotics, eigenvalue is stability or frequency of a motion, and eigenvector is direction of or mode of motion. Let us see the one example. Consider a equal to a b c d. So finding the characteristic equation, which means that determinant of a minus lambda a equal to 0. Therefore, determinant of this matrix a minus lambda I equal to 0. Next, solving for lambda, so we get the solution. Solving for eigenvalues by this equation, from this equation, so we get the eigenvalues. From these eigenvalues, we have to solve the eigenvector. Procedure to find the eigenvalues and eigenvector. First one is the find characteristic equation of the given matrix. The second step is obtain the eigenvalue from solving the characteristic equation to find the eigenvector for the corresponding eigenvalue. Let us see the next example in next video. Thank you.